Hello, my name is Christian McCollum here with the VLF team at ASU. Again, our overall goal for this project is to design a very low frequency detection device that will be mounted onto a UAV in flight, which we will be trying to detect frequencies from radio towers and lightning strikes. Since the last video, my personal job has been linked to coding the Raspberry Pi and Arduino Uno, which are two essential components that we'll be utilizing for data storage and data transmission to pick up the frequencies. So far, I've successfully paired both of those, and I'll also be working on, I've been working on the whip antenna portion because we were utilizing 3 different antenna designs for the project. So far, I'm near completion with all of that, and for 489, I plan on utilizing time to perfect the design process and perfect the code for the Arduino Uno and Raspberry Pi. Thanks.
Hi, my name is Makaya Di Silvestro. I'm with the VLF team, and the mentor that we have on our team is Dr. Ali. And what we've done so far is the team has designed and simulated a receiver, which is just a preamp and filter. And we have physically built this in the lab and tested it with the signal generator. It has good gain, it seems to be pretty sensitive, and it does seem to attenuate the frequencies we do not want, which is anything after 100 kilohertz. We also have ferrite rods. We have several different sizes of ferrite rods. The ferrite rod we're using right now is 4 inches by ½ an inch, and we put 60 turns on it and found that we had 4 millihenries at 60 turns. For testing purposes, we just left it just to see if it worked with the signal generator. Now we just need to reduce the number of turns and find where it's at 1 millihenry and then glue it so the wire doesn't come off. So that's what we've done on campus so far.
Hello, my name is James Jacobs and I'm on the VLF team. Currently, as it stands with our team's progress, we've made a receiver and conducting testing in a lab. And we're currently making adjustments to equipment because obviously we'll have theoretical outcomes and practical outcomes to our results because of variances in the manufacturing of not only the equipment that we're making, but the actual instruments that we're using to measure such readings. I'm currently working on a loop antenna, and I'm doing R&D at my home just for the best possible design. I'm considering things such as aerodynamics, considering the positioning and weight of the antenna itself, and experimenting with different gauges of wire because with different gauges of wire I'll have to loop the actual the antenna more or less. So I'm doing some experimenting with that. And I'm continuing to maintain communication with my team to ensure that we can have the most cohesive and effective design as possible. Thank you, and I look forward to updating you next time.
Hello, my name is William Howell. I'm a part of the VLF detection group under the mentorship of Dr. Ali. This past semester, we've been planning our project in addition to testing out our current amplifier, antenna, and filter design in the GWC 331 lab. The future of our project for next semester revolves around connecting each component of our hardware together and arranging it so that it is able to act as a payload to our UAV. Designing our receiver that complies with the size and weight constraints of our aircraft is one of the challenges that we will have to tackle for 489. As of right now, the amplifier and filter of our design is finished, with the antenna still under construction. The analog to digital converter and data storage device is still having its kinks worked out in terms of software development, in addition to further evaluation of specific hardware components that will be used as per the design process. Once every component is working on its own, we can then proceed to link every section of our hardware together to produce a receiver that can detect very low frequencies and store that data for further analysis.